Hello everyone, welcome to another video on integration. In this video, I'll be focusing on integrals which involve square roots of quadratic functions. If you're new to this channel, please support the channel by subscribing and sharing videos on this channel and providing feedback on the work that we put out. We absolutely appreciate your feedback. To those that have already subscribed, we thank you for your support. Now let's look at our first integral for today. And in this video, we are supposed to integrate x to the power 5 square root of x squared plus 1 dx. This is a quadratic expression under the square root sign. Now, if you differentiate this, you're going to find 2x, but we have x to the power 5 outside, which means we have to do something. Obviously, we're going to use u substitution in this case. I'm saying obviously because the best way to get rid of this is to say let u squared be equal to this, because you have a square root sign. But then here you have x to the power 5, so we need to work on this. So this is how we approach it. Question 1, let's capture the entire integral as it is. X to the power 5 square root of x squared plus 1, and then we are saying dx. Now watch what I'm going to do. This expression here, x to the power 5, I'm going to work on it. So this is equal to the integral of, watch what I'm going to say. I'm going to take 1x from there and put it next to dx. Why? Because the derivative of x squared plus 1 is 2x. At least I have an x there. So I'm going to say x to the power 4 times square root of x squared plus 1, and then I'm going to say x dx, like so. Now, I have x squared plus 1 here. I can produce x squared from there. So I'm going to rewrite this in my next step as the integral of x squared, and I'm going to say the whole of this squared, and then I'm going to say square root of x squared plus 1, and then I'm going to say x dx, like so. At this stage, I'm going to let u squared be equal to x squared plus 1, this expression under the square root sign. And so, differentiating both sides, you are going to have, if you agree with me, 2u du on the left. On the right, we're going to have 2x dx. Remember, derivative of 1 is 0 because 1 is a constant. Cancelling the 2's, we have u du is equal to x dx. Now, that is taken care of. But I have x squared here, so I must solve for x squared in this expression here. Solving for x squared here, you'll agree with me that x squared is actually going to be u squared minus 1. Solving for x squared, subtract 1 from both sides, you're going to get this expression here, u squared minus 1. So now I have to get rid of this expression, and that expression. Triple substitution, so to speak. So that integral then changes to the integral of, watch, in the place of x squared, I'm going to place u squared minus 1, but it has to be squared. So u squared minus 1, all squared, and then I'm going to say square root of, remember x squared plus 1 is u squared. So I'm going to put u squared there, and then outside x dx is actually u du. So this is u du. Now what is square root of u squared? The answer is u. And expanding this expression here, I'm going to have the integral of u to the power 4 minus 2u to the power 2 plus 1 in brackets, and this is u times u du. Moving on, we have the integral of, this is u to the power 4 minus 2u power 2 plus 1. Outside we have u squared du. Let's distribute the u squared. That takes us to page number 2. Page number 2. Right, so what are we saying? Can you see the information there? Yes, you can. So now we are saying this is going to be equal to the integral of, distribute u squared, we're going to get u to the power 6 minus 2u to the power 4 plus u squared, and we are saying du. Now distributing the integral sign and the du, we have the integral of u power 6 du minus 2, the integral of u to the power 4 du, plus the integral of u squared du. Right, if you follow what I'm saying, that 1, 2, 3, we have to have the expression simplified like this. Now let's integrate each of the terms. That one there, remember, the integral of u to the power 6 is just going to be u to the power 7 all over 7. We add 1 and divide. Minus 2, the integral of u to the power 4 is actually u to the power 5, and we have to divide by 5. And then plus, that plus sign, the integral of u squared is u to the power 3 all over 3. And then I have to say plus a constant. Now rewriting this, we're going to have 1 over 7 u to the power 7 minus 2 over 5 u to the power 5 plus 1 over 3 u to the power 3 plus c. Let's move back to our original variable. Our original variable is x. Now notice something here. U squared is equal to x squared plus 1. From here you can actually solve for u. U is going to be the square root of x squared plus 1. This is the value of u. So square root of x squared plus 1. And please take note of the fact that this can also be written as x squared plus 1 to the power half. That's the meaning of square root. Now I'm going to bring this one and put it in the place of u. So coming back here, coming back to our last step where we stopped, this is going to be 1 over 7. Remember now I'm saying we have x squared plus 1 or the power half, but we have outside power 7, and then minus 2 over 5, and we are going to do the same, x squared plus 1 to the power half or to the power 5. There it is. And then I'm going to say plus, we are here 1 over 3, we are saying x squared plus 1 or to the power half, and then we have a power outside of 3 plus c. Now multiplying the powers by using laws of exponents, you'll agree with me that the final solution is going to be 1 over 7, and then I'm going to have x squared plus 1 to the power 7 over 2, and then I'm going to have minus 2 over 5. We're here. It will be x squared plus 1 to the power 5 over 2, and then I'm going to say plus, coming here, it will be 1 over 3, and then I'm going to have x squared plus 1 to the power 3 over 2, and then plus my constant c. So this is the final solution then to our integral. Remember, this is the integral we're talking about here. Our first integral is this one, x to the power 5 square root of x squared plus 1. And this is how it works. A lot of work to be tricks performed here. By observing what is under the square sign and looking at what is outside, you can somewhat construct what you have there outside and then carry on. We had to produce x squared there. Yeah, so this is how it's supposed to be done. Advanced techniques of integration. Let's move on to question number 2 for today and in this video. Question number 2, here it is. Now we have the integral of square root of 4 minus x squared dx. Now, how do we approach this? When you see the minus there, x squared, what comes into your mind is the trig substitution and sign substitution to be specific. So here is how we approach it. We're going to page 3 now, and this is our question number 2 of 4. We have 4 questions to go through. Question number 2. It says the integral of 4 minus x squared, and we're supposed to take square root of that, and then dx. Now watch what I'm going to write here. I'm going to say the integral, that integral can be transformed into square root of, I'm going to factorize that expression, take 4 out. 4 into 4, 1, and then into that one there, x squared, I'm going to have x squared over 4, like this. And then I have dx outside. Now take 4 out because we're taking square root of 4 now. Take 4 out. The answer is the integral of 2 square root of, watch this, 1 minus, and how I'm going to write this is x over 2, and I'm going to square the whole thing. Because if I write it like this, it will be, let me clean up a little bit, if I may. I'm going to clean up just a little bit over here so that the 2 is clearly seen. Perfect. And up there, just so that the x is clearly seen, right? So now I'm saying that if you expand, you remove these brackets, you're going to get x squared over 4. But the reason I'm doing this is because I want to use the identity sine squared plus cosine squared equals 1. So yeah, so we have dx outside here, and 2 is a constant, we can take it out, so that's 2, the integral of square root of 1 minus x over 2, and all over all that expression we have to square it, and we're saying dx outside. At this stage, I'm gonna let watch this, sine of theta be equal to x over 2, that expression there. At this stage, it's important for us to go straight to a triangle, right angle triangle, and define that theta as this angle here, and then sine, remember sine is opposite over hypotenuse, so that would be opposite x, hypotenuse would be 2, and to work out the adjacent side by Pythagoras theorem, you'll agree with me that this is actually square root of, you square that is 4, and then minus that squared. That would be the adjacent side, right? Now, let's take this expression here, and we're going to differentiate both sides. First, multiply by 2 both sides. So if you multiply by 2 both sides, you're going to get 2 sine theta is equal to x. And then now differentiate both sides. If you differentiate both sides, you're going to get, you can see it there, here, you're going to get 2 cosine of theta, d theta, is equal to dx. Now, that is taken care of because dx equals this expression. And in that place, I'm going to put sine theta. It will have to be squared. Right. So let's move on to page number 4 now. Yeah, page 4. There you go. So now, like I said, we're going back into our integral. Which integral are we talking about? This one here. 2, the integral of square root of 1 minus x over 2 all squared, and then dx. We're changing that. Obviously, the 2 outside must remain there. So our integral now changes to, I'm going to do this. That integral will change to 2, the integral of square root of 1 minus sine squared theta. And outside, remember, we are supposed to have 2 cos of theta d theta. That one there. You can see it there. Right. Now, we know that sine squared theta plus cos squared theta equals 1. Solving for cos squared theta here is going to be equal to 1 minus sine squared theta. So where there is this, I must put that. So therefore, this integral changes to 2, the integral of square root of cos squared theta. Outside, I have 2 cos of theta d theta. Now this 2 can come out. We'll multiply with that 2. I'm going to have 4, the integral of this is, as you know, this simplifies to cos theta. And then I have cos theta here. And then I have d theta. So what is this? This is 4, the integral of cos squared theta d theta. Now I have to remind you of what we call double angle formula for cosine. The double angle formula for cosine says cosine of 2 theta has 3 expressions. The first one is cos squared theta minus sine squared theta. The second one is 2 cos squared theta minus 1. The third one is 1 minus 2 sine squared theta. We're going to take this one because that's the one that contains cosine of theta, cos squared of theta. And we're going to solve for that. So now we are saying, therefore, cos of 2 theta is equal to 2 cos squared of theta minus 1. Making cos squared of theta subject to formula, you're going to add 1 on both sides and then divide by 2. So you can see that this is cos squared of theta is just going to be equal to 1 plus cos 2 theta all over 2. So this expression here must come into that space. And I'm going to have d theta there. Right. So we're moving on then. This integral changes to, we are now on page 5. That integral now changes to, remember, we are talking about this integral here. Let me just show you. We're talking about this integral here. It changes to 4, the integral of, instead of that, I'm going to have this expression, and then I'm going to have out there, I'm going to have d theta. So now we are saying for the integral of, I'm going to have 1 plus cos 2 theta all over 2, and then I'm going to have d theta here. I'm going to have that. Now, all right. So now you can see the 2 is dividing. These 2 cancels into 4 there. The answer is 2. And I'm going to have the integral of, if you like, 1 plus cos 2 theta. And then I have d theta. Distributing that and keeping the 2 outside, I have 2. And I'm going to say the integral of 1 d theta plus the integral of cos 2 theta d theta, like so. And integrating 1 with respect to theta, you agree with me that this is just theta plus the integral of cos 2 theta is actually sine 2 theta all over 2. Please convince yourself that that is exactly correct by using u substitution. Maybe let's just do that because we have a bit of time. Let's just do that straight away just to show you that that's correct. I don't want to use this page. It's page 7 because these pages are numbered nicely. So let me just get a separate page here. This is page 6. Yeah, page 7 must remain there. I'm going to get a separate page somewhere down here. Right. So what I want to do is show you that I want to show you that the integral of cos 2 theta is actually sine 2 theta over 2. So here is how it works. The integral of cos 2 theta d theta, you're going to let u be equal to 2 theta. You understand what I mean? 2 theta. And what is du? The answer is 2 d theta. Divide by 2 both sides. All over 2, all over 2. These cancel. And what do you have? You have du over 2 equals d theta. So this integral then changes to the integral of cosine of u. And then I have du over 2. Take 2, we have out. 1 over 2. The integral of cos of u du. What is cosine of u? Well, cosine of u is actually, the integral of cosine of u is actually sine of u. And what is u? U is basically 2 theta over here. There is 2 theta. So we have 2 theta here. So the integral of cos 2 theta is actually half of sine 2 theta. That's what I've written here. Right. So now this is what we have. And we are supposed to now say plus c because we're done with the integration. Distribute the 2. You're going to have 2 theta plus these 2 cancels that. So you're going to have sine 2 theta plus c. Now, let's work on this. This one here, we know the expression for theta. The expression for theta, where are we coming from? If I take you to the page where we're coming from, here we go. We started from here. Remember, this is the relationship between theta and x. So if you want to solve for theta here to be the sine inverse or inverse sine of x over 2. And from here, we can work out the cosine. Now, so double angle formula for sine, this is going to be, let's keep this one the way it is for now, plus this double angle formula for sine, this is 2 sine theta cos theta. And then we have a plus a constant there. Now, this is going to be 2. Now, I'm going to get rid of theta. From here, again, theta equals inverse sine of x over 2 or sine inverse x over 2. So this is sine inverse. Some people say inverse sine x over 2. And then plus 2 sine theta. Excuse me, what is sine theta? X over 2. So I'm going to have here in that place times x over 2 times, what is cosine of theta? Remember, this triangle I told you is critical. Cosine of theta, it will be this all over 2. So square root of 4 minus x squared over 2. Square root of 4 minus x squared all over 2. And then plus c. Let's clean up. So this is equal to 2 sine inverse of x over 2. These 2's cancel. These 2 cancels that. And I'm still going to have half there. So plus half x. And then I'm going to say square root of 4 minus x squared and then plus c. So this is the final solution to our integral number 2. And integral number 2, just to remind you, is this one here. This is our integral number 2. It's our second integral. There it is. And we've just gone through it, and we are already above 20 minutes. Let's move on. We have 2 more integrals to evaluate. Right, so now we're moving on to this is now going to be our page 6. Our third integral is this one. Now we are supposed to integrate dx all over x plus square root of x. Now, how do we approach this? Obviously, your guess is correct. We're approaching it from square root of x. So let's just capture the question exactly how it is. The integral of dx all over x plus square root of x. We're going to say at this stage, let u squared be equal to x, and differentiating both sides, 2u du equals dx. Now I'm going to do the, remember here it's x, so x is u squared. So I'm going to put u squared there. I'm going to put u squared under the square sign, and I'm going to put 2u du in the numerator. So this integral then changes to the integral of 2u du all over u squared plus square root of u squared. So this is the integral of, put 2 outside, u du all over u squared plus u, because square root of u squared is u. This is 2, the integral of u all over, of course we have du there. Factorize the denominator, you have u plus 1. Notice these cancel. So what do we have now? We have 2, the integral of du all over u plus 1. And this, if you allow me to move straight and say that integral is just 2 natural log of u plus 1. Like so, plus c. The integral of 1 over u plus 1 is just natural log of u plus 1. Let me again, I feel obliged to show you that that's the case. Let me, although it's taking much of our time, but let's just show it. We're saying the integral of du over u plus 1, which can be rewritten as the integral of 1 over u plus 1 du. If you let t be equal to u plus 1, what is dt? Is going to be equal to du. Now come back here, this integral must change to the integral of 1 over t dt. And you must remember, you should remember that this is actually natural log of t. And what is t? T is actually equal to u plus 1, u plus 1. So this is correct, that integral of that is just the natural log of u plus 1. So where are we at? We are over here. Let me just put the papers in correct order here, and I move this one to the left a little bit. Fantastic. So this is what we have. But remember now, our original variable is not u. What is our original variable? Is x. So solving for u here, you'll agree with me that this implies that u is actually equal to square root of x. That's what it is. U equals square root of x. So at this stage, we're going to say this is equal to 2 natural log of inside brackets there, inside the absolute value signs. Remember, this is 1. So I'm going to have 1 plus square root of x. I like to write 1 first before I write this. Otherwise, it would be very easy for someone to confuse this with square root of x plus 1. And I don't need to put absolute value signs anymore, because this can never be negative. The whole expression can never be negative. So I'm now going to say that I told you in the previous video, or maybe a couple of videos back, I told you that sometimes the absolute values can be dropped. This is a typical example. So this is our final solution, and the assumption, obviously, the assumption is x must be what? Must be greater than or equal to 0. That's the assumption. X must be greater than or equal to 0. That's the assumption. because square root of a negative number is not real. So this is our final solution. Remember, we started from here, and this is our final solution. Was a bit short, this one, and a bit simpler than the other two that we've looked at so far. Right, let's move on to our integral number 4, the last one in this video. That takes us to page 8, integral number 4. There it is. Not so much square root of something, but you know, we have quite a unique integral here. X to the power 4 plus 1 in the denominator, and then we have 2x in the numerator. The question is, how do we handle this? If you differentiate that, you'll see that it actually gives you 4x cubed, and we have 2x in the numerator. So we have to do something on this one here. So this is how we approach it. Very unusual integrals. Number 4. This is a very unusual integral, like I said, 2x. In fact, all the integrals we've looked at so far are not very straightforward. This is over x power 4 plus 1 dx. We're going to rewrite that to the integral of 2x. Allow me to put dx in the numerator all over, and then I'm going to say x squared all squared plus 1. Watch that moment of brilliance right there. We are now going to say let u be equal to x squared. And what is du? Is 2x dx. Watch what happens. So now I come back here, and I say this integral then changes to the integral of du in the numerator all over there. Remember, we have x squared squared, so it's going to be u squared plus 1. U squared plus 1. Like so. At this stage, we're going to say let tan theta be equal to u. Differentiating both sides, we're going to have sec squared theta d theta equals du. Coming back here, this is going to be, that integral is going to be the integral of, in the numerator, I have sec squared theta d theta. In the denominator, I'm going to have tan squared plus 1. Tan squared theta plus 1. This is actually sec squared. Again, I feel that for someone who is watching this video and has not watched some of the videos I presented already, for continuity's sake, must explain how that tan squared theta plus 1 is sec squared theta. Let me explain on this page here. We know that sine squared theta plus cos squared theta equals 1. We know this. Right. Let's divide throughout by cos squared theta, assuming cos squared theta is not equal to 0. So this is sine squared theta over cos squared theta plus cos squared theta over cos squared theta equals 1 over cos squared theta. Now, this is tan squared theta. You can see sine over cosine is tangent, plus 1. What is this? Sec squared theta. So that's why I was saying this equals that. It comes from there. Now, so therefore we're going to say, we're moving now to page number 9. And I'm going to move this one down a bit so you're able to see everything I'm writing. Fantastic. So now I'm saying that therefore can be written as the integral of sec squared theta d theta all over sec squared theta. And these cancel. So what do I have? The integral of 1 d theta. And I've shown you in the previous videos that this is just theta. And we have to say plus c. Now what is theta? Let's move back to our original. We're supposed to move back to our original variable. This theta is not our original variable. So we're moving back here first of all. Remember, we're supposed to say theta equals tan inverse of u, or inverse tan u. So this is going to be tan inverse of u plus c. But what is u? We're moving back. U is x squared. So this changes to inverse tan, or tan inverse of x squared plus c. This is our final solution to our integral, this one here, 2x all over x power 4 plus 1 dx. Our final solution is that one there. We have had to use u substitution and also the trig substitution, the tangent one. All right, I'm going to stop here in this video. Like I said at the beginning, if you're new to this channel, please support us by subscribing, inviting friends to subscribe. All these are past exam questions. If you're preparing for Calculus B exam, these videos will go a long way in helping you achieve your desired academic score. Right. God bless. See you next time.